Hello, students. How are you? Hope you are doing well. Today, we are going to learn the refraction of light and its uses. But before that, we are going to learn some new vocabularies. First, refraction. Again, refraction. Let's spell refraction. R E F R A C T I O N. Refraction. Next word, reflection. Again, reflection. Let's spell reflection. R E F L E C T I O N. Reflection. Last word, ray of light. Again, ray of light. Let's spell ray of light. R A Y O F L I G H T. Now let's proceed to our topic for today. What is refraction? It is a bending of light as it passes through different materials. Again, let's read it one more time. It is a bending of light as it passes through different materials. As you look at a fish in a tank, the light bends as it passes through three different mediums: the water, the glass of the tank, and air. As the light passes from one medium to the next, it refracts. Here is a sample video.
Demonstrating optical phenomena in the classroom can be difficult. The trouble is, light beams are invisible. Normal scattering agents such as chalk dust are messy and can cause other problems in the classroom. The laser viewing tank allows students to see and manipulate light beams in a lab group setting. These tanks act as student workstations, so you can set up a bunch with little time or fuss. When I aim a laser into the tank filled with pure water, the beam can barely be seen. When I add a small amount of scattering agent to the water, the beam becomes highly visible. Some light is reflected from the agent's particles as the beam passes through the water. But we're going to dim the lights so you can see what's happening. Next, I'm going to aim the laser down toward the water at an angle to see refraction in action. Look how the direction of the beam changes when it enters the water. Set the tank at the edge of the table and aim the beam upward to see refraction again. If you increase the angle of incidence by aiming the beam through the water from the side of the tank, you will observe total internal reflection. When a source of white light is sent through the tank, the light appears blue from the side because the short blue wavelengths are scattered more than any other. Looking through the end of the tank, the light appears to have a reddish tint because all of the blue wavelengths have been filtered out through scattering. You can also use diffraction gratings with different numbers of lines to observe interference patterns. Look at the well-defined maximum. There are so many characteristics to explore.
Refraction can allow you to see the image of something at one location when the object is actually in a different location. When light rays enter a medium at an angle, the change in speed causes the rays to bend, thus changing direction. Here is another sample video.
Refraction of light through a glass slab. For this activity, we will take a black paper as a background for laser beam. We have placed 4 tablets on the black paper, which serve as a platform for the glass slab. Friends, these are simple paracetamol tablets used to raise the glass slab slightly above the surface for better clarity of the laser beam. For the activity, we are taking a powerful green laser torch. Now switch it on. We can observe the laser beam travel in a straight line in air medium, but when it is passing through the glass slab, it bends. This bending of laser beam or visible light when it travels from one transparent medium to the other is known as refraction of light. Let's first discuss refraction with normal incidence of laser beam. Here, the laser beam is falling normally on the glass slab. That means angle of incidence is 0 degree. So here, light travels straight in glass slab without any bending or refraction. Now change the direction of laser beam and increase the angle of incidence. You will observe a slight bending of laser beam towards the normal in the glass slab. Increase the angle of incidence further and you can see the amount of bending of laser beam also increases. Observe the refraction of laser beam through a different angle for better clarity. Here you can see in air medium the laser goes straight, but when it enters the glass medium, bending takes place.
Please refer to Figure 6.6 Refraction of Light by Different Objects on your science books to page 87. As shown in the illustration, Figure A shows the ray of light from air passing through a plastic bar. Figure B shows the ray of light from the plastic bar into the air. Figure C shows the combination of this effect. Some mediums cause light to bend more than others. When light passes from air into water, it slows down. Light slows down even more when it passes from water into glass. When light passes back from glass back into air, it speeds back up. Light travels fastest in air, a little slower in water, and slower still in glass. Glass causes light to bend more than light does in air or in water. Here is another sample video.
Have you seen any simple everyday examples of refraction? One thing that you might have noticed, or you can try yourself, is take a pencil and put it in a glass of water. The pencil will appear bent. It's due to refraction of light.
From this fact, we say that glass has a higher index of refraction than either air or water. A material's index of refraction is a measure of how much a ray of light bends when it enters that material. Additional knowledge. The higher the index of refraction, the more it bends light. The index of refraction of water is 1.33. For glass, it is 1.5. So light is bent more by glass than water. Now, let's have a review. What is refraction? It is the bending of light as it passes through different materials. Again, what is refraction? It is the bending of light as it passes through different materials. For our activity, please open your science books to page 88 and answer activity 6.6, Vision of Object in Water. You may write your answers on your notebooks or a piece of paper. Number 1. Place a pencil in a bowl of water and observe the image. Notice how the pencil now looks different. Number 2. What has happened to the image as the light is refracted into the water? That's it for today. Hope you learned a lot. See you on the next topic.